What's up guys, welcome back to the channel. Today on this video I will be deriving double angles that we usually use in trigonometry. So on our last playlist or last videos we were doing compound angles. So if you are not so sure about compound angles, there is a playlist that where you can go and watch compound angles and also the application and proving using compound angles. There's tons of videos there. There's at least about 7 to 8 videos whereby we use double angles. And also the first video, that's where we show the formulas for double angles for all three trigonometric ratios: your sine, your cos, and your tan. Now on this video I'll be deriving the well-known common double angles that we use in trigonometry. If you don't know them, this is the double angles that I'm talking about, guys. These are the ones that I'm talking about. We have this one here whereby we have sine 2x, which is equaling to 2 cos x multiplied by sine x. Right, so this is one of the double angles that we're going to derive. And then we have this one here for cos 2x, which has three identities. So one of the identities is 2 cos x squared and then minus 1. And then the other one for the very same double angle is 1 minus 2 sine x squared. And then the last one, which is also the identity, with cos squared x minus sine squared x. X. So these are the identities that we're going to prove, or we're going to derive, guys. These are the double angles that we're going to do. So for cos, as you can see, we have 1, 2, and 3. So this is for cos. And then for sine, it's only 1. So I'm going to start with deriving the first double angle, which is for sine. It's really not that difficult. It's very simple. In order for you to derive this double angle, you're going to need to do the following. Let me just write it here so that we can have enough space. Sine 2x. So in order for you to derive this one, you need to rewrite it like this. If you still remember, you can say sine and then say x plus x. So if you say x plus x, you're gonna have 2x there. That's obvious. So in order for us to derive this, we need to use the compound angle. So the compound angle for sine, we know that the general formula for it is sine. Let me just write it below here. A plus b, and is equaling to sine A multiplied by cos B plus or minus sine B multiplied by cos A. Right, this is a formula for sine compound angle. But now look at this, guys. Look at this. This one has sine x plus x. So if we decide to use this formula for sine, it's gonna be sine. So in this case, A is x multiplied by cos, which in the same case B is x. Since we have positive here, this is gonna be positive as well. And then this is gonna be sine x multiplied by cos x. So when you look at this, the first term and the second term, they're the same. So what's gonna happen? They're gonna add, and then this becomes 2 sine x multiplied by cos x, which is the same as this one here, which is the same as this one here, guys. As you can see, this and that, it's one and the same thing. So this one is very simple, guys. It's straightforward. If they ask you to derive the double angle for sine, then you know it's very easy. But what about the double angle for cos? Because cos has about 3 of them. It has 3 of them. So I'm gonna try to open up a space for us so that we can able to have enough space to solve them. But I'm gonna leave them there on the screen. So let's do for cos. So let's start with let's start with this one here. Let's start with the one at the bottom. So remember, cos as well is the same as cos 2x, right? So you're gonna rewrite this as well, and then you write cos x plus x. So again, using a compound angle formula, so we know that cos is the same as cos plus minus b, cos a plus minus b, and then we have cos a multiplied by cos b. Then since we have this is plus or minus, by the way, and then sine a and sine b. So this is the general formula for cos. But now if we decide to use this one, we're gonna do it this way. We're gonna say cos, x multiplied by cos x. Since we have a positive sign here, we're gonna have a negative sign. Remember, with cos it's vice versa, and then sine x multiplied by another sine x. As you can see, on the first term we're gonna have cos squared x, minus on the second term is gonna be sine squared x. As you can see, this one that we just did is the same as the one at the bottom here. I hope you guys can see the same as the one at the bottom here. Let me just highlight it for you again. The same as this one, guys. Can you see? So it's the same as this identity. So that one was very easy. If they do ask you to derive it, so you know it's gonna be very, very simple. Now what about the other two? So I'm gonna do the other one on top. Let me just scroll down again, just a little bit, yes. So I'm gonna do it here. I'm gonna do the one on top, by the way. So I'm gonna take it exactly from this part here. Let me just draw a line so that you can see where we are. So I'm gonna take it from there. So since we have cos squared minus sine squared, now in order for you to do the one on top, you need to replace the sine with cos. So we have this identity here whereby sine squared plus cos squared is equaling to 1. So if you decide to make sine substitute formula, you can have this following, by the way, guys: squared x, and then we have 1 minus cos squared x. So we can substitute this here on this sine squared. So let's do it. So if we substitute, we're gonna have cos squared x and then minus. Now instead of putting cos squared x, so we can put 1 minus, instead of putting sine squared x, we can insert 1 minus cos squared. So it's going to be 1 minus cos squared x, right? Now we continue. As we continue, this is going to be cos squared x, and then minus, we multiply by -1 throughout. This is going to be plus x, it's going to be plus cos squared x. And then as you can see, cos squared x plus cos squared x, you're going to have 2 of them. So you're going to have 2 cos squared x minus 1. As you can see, this one right here, guys, is the same as the one on top there. So that's how you derive that one. So how about the other one? How do you derive the second one? This one here. Where is it? Where is it? How do we derive this one here? So let me just open up some space for us. Let me just leave it like that. So I'm gonna take it from here as well. I'm gonna take it from here, and for this one I'm just gonna go back a bit. I'm gonna take it from here. Alright, I'm gonna take it from here. Okay, so but before I do that as well, I'm still gonna use this identity, guys. This time around I'm gonna make cos substitute formula. So if I do make a cos substitute formula, can I do it here? So it's gonna be cos squared x, which is equaling to, if you take sine to the other side, it's going to be 1 minus sine squared x. So from here, we take it from here, wherever there is cos, we substitute with 1 minus sine x. So it's going to be 1 minus sine squared x, then minus sine squared x. Remember, we have minus sine squared here, and then from there we have negative sine squared x and another negative sine squared x, and then they're gonna add up and they're gonna give you negative 2 sine squared. So when you write this, gonna write it like 1 minus 2 sine x squared. 2 sine squared x. So this is gonna be your third one here. This one right there. This one right here. So basically, this is how you derive the double angles. Guys, I hope you understand. If it so happen that you don't understand, you can always go back and rewatch this, and also you can comment if there's something that you didn't understand. Probably gonna try to explain as much as I can in the comment section, and as well you can share this video, and do not forget to like and subscribe to the channel if you find this information useful. Thank you very much, guys, for watching. Till next time, cheers.